right, so you want to build this low latency, multi-language ASR service with live transcriptions, right, for your home network. And you want to get to the heart of it like fast. That's what we're here for. We've gone through like a ton of sources on this, stacks and stacks, just so much stuff.
Yeah, there's a lot out there.
Yeah. But we're going to get this down to like the essentials, right? So you can actually build this thing.
Exactly. And focus on speed and making it practical, for a real home setup.
Absolutely, yeah.
What's really cool about this is we're taking these really complex AI speech models and we're going to figure out how to make them work right in your house.
Right in your house.
Imagine real-time transcription, but it's all powered locally.
Yeah. So let's get into the nitty-gritty, the core of how this works. Most of the modern automatic speech recognition, ASR, uses, these deep learning techniques, which are super powerful.
Yeah, they're amazing, but they can be a little slow sometimes, especially if you're aiming for real-time results.
That's the thing, right? It's that delay. But there's some really interesting new developments, like this thing called Moonshine.
Oh yeah, Moonshine is designed for live processing. It tries to be much more efficient. It uses something called rotary position embedding.
Okay, interesting. But for multiple languages, it seems like OpenAI's Whisper is like the go-to option, right?
Absolutely. Whisper's ability to understand so many languages is amazing. It comes from the huge amount of data they use to train it. But to make it work in real time, to get that snappy response you need, we have to look at ways to make it even faster.
I see, yeah. So that's where the optimized Whisper versions come in, right? Like faster Whisper. That seems to be the ticket for getting that low latency we're after.
Yeah, faster Whisper is looking very promising. And for your home setup, a client-server model is probably the most straightforward way to go.
Makes sense. Keep it simple. Right.
Exactly. A central server that handles all the processing, and then you have your devices acting as clients. And to get that live transcription feel, we need a constant stream of audio coming in, which gets processed in small chunks.
Right. So it's not like waiting for a whole file to upload. It's like constant little bits of audio coming in, and the transcription is happening as you speak.
Right. Exactly.
Okay. So Python seems like it's the go-to language for the back end, and then there are frameworks like Flask, FastAPI, and Tornado. FastAPI seems like it might be a good option here, right?
FastAPI is great because it can handle things asynchronously, which could give us a performance boost when dealing with real-time audio streams.
Okay, that makes sense. And what about the core components of the backend? I mean, what are the essential pieces we need to make this thing work?
Well, you'll definitely need something to handle the incoming audio, right? So taking that audio stream and getting it ready for processing.
Right.
And then something I think is really useful here is voice activity detection, VAD.
Oh, yeah. Tell me about that.
This is a way to ignore the silence, basically. So the ASR model doesn't waste time processing parts of the audio where nobody is speaking.
Oh, that's smart. So that saves processing power and time.
Yeah, it can really help reduce those precious milliseconds of latency.
I see.
And of course, we need to integrate Faster Whisper itself. That's the brains of the operation.
Yeah.
And then finally, we need a way to send out the transcribed text to display it on your devices or wherever you want to use it.
So the output, yeah, okay, that makes sense. Now, how do we actually get the audio from our devices, like our phones or computers or whatever, to this central server?
Okay, so if you're using Python on your client devices, there are libraries like Sound Device or PyAudio. Those are pretty standard for capturing audio. And then to send that audio to the server and get the transcriptions back, WebSockets seem like a good fit.
WebSockets? Why WebSockets?
Well, they keep a constant connection open, so you can just stream audio and get text back in real time without any interruptions.
Oh, I see. So it's like a two-way street constantly flowing.
Exactly. Now, there's also something called gRPC, which is more structured, but it might be overkill for this kind of setup.
Right. We want to keep things streamlined if we can.
Exactly. And if you're building like a web app, you can use JavaScript and WebSockets on the client side to do the same thing. Capture audio and send it to the server.
But is it easy to get audio, like system audio from a web browser? I feel like that can be tricky.
You're right. It can be a bit more challenging. There are ways to do it, but it depends on the browser and the operating system. And what if you're working with Unity, like for a game or something?
Oh, interesting. What about Unity?
Unity has its own API for accessing the microphone. It's built right in, unityengine.microphone. And guess what? You can still use WebSockets there. There are libraries like WebSocket Sharp that make it pretty easy.
So WebSockets are really versatile.
Yeah, they are. Unity also has an option for using something called WebRTC, but it can be a bit more complex to set up than WebSocket.
Right. We're trying to keep things like relatively straightforward, right?
Yeah, definitely. Okay, so let's get into the heart of this. Faster whisper. What makes it tick?
Okay, yeah, let's dive into that. What's the magic behind it?
Well, it's built on something called C Translate 2, which is really the secret sauce. It makes faster whisper much faster, like up to 4 times faster, and it uses less memory than the original whisper. But it still has that amazing multi-language support, understanding over 100 languages.
Wow. So it's faster, more efficient, and still understands a ton of languages. That's impressive.
Right, and there are even projects built on top of it, like real-time STT.
What does that do?
It takes faster whisper and adds things like VAD and even wake word detection. So it's getting even closer to that always listening kind of functionality.
Okay, cool. So we've got the software side, the models, the frameworks. Now, what about the hardware? CPU versus GPU. What are we looking at here?
Right, hardware is crucial for performance. So GPUs are designed for parallel processing, which is exactly what these AI models need. And that means like significantly lower latency for faster whisper.
Oh, so it's not just about raw processing power. It's about how the processing is done.
Exactly. And even older GPUs can be surprisingly good at this. Now, CPUs can run the models, but they're generally slower for real-time tasks. Smaller models might be okay on a CPU, but for that super low latency, especially with the larger models, you really want a GPU. And make sure it has enough video memory, VRAM.
Yeah, VRAM is important for these kinds of things.
Yeah.
So you're saying if we want that snappy instant transcription, especially with lots of languages in a large model, a GPU is the way to go.
Pretty much, yeah. The performance data really shows that difference. The time it takes to transcribe with a GPU versus a CPU, especially for larger models, it's like night and day.
Wow. Okay, so thinking practically, what do we need in terms of resources for all of this?
Okay, so for your CPU, having multiple cores is going to help. It allows it to handle all the different tasks efficiently.
Right.
And the RAM you need depends on the model size. Bigger models need more memory. And also how many devices you might be using at once. More users means more memory usage.
Yeah, that makes sense.
And you'll also need some storage space for the Docker image itself and for the model files.
Docker, you mentioned Docker. Why is that important?
Docker is awesome for setting this up at home because it basically packages everything together neatly. It creates this isolated environment where everything just works, so you don't have to worry about dependencies or conflicts or anything like that.
Right, so it makes deployment much easier.
Exactly. And there are already faster Whisper Docker images available out there, so you don't have to start from scratch. Now, if you are using a GPU, you'll need to set up something called GPU pass-through.
GPU pass-through, what's that?
It's basically a way to let Docker access your GPU. You'll need to use the NVIDIA container toolkit for that.
Okay, sounds a bit technical, but doable.
Oh yeah, there are good guides out there for setting it up. All right, let's recap all of this. What's our ideal setup looking like?
Right, bring it all together, the big picture.
So it seems like faster Whisper with a Python backend, maybe using FastAPI, and using WebSockets for communication is a pretty solid plan.
Sounds good.
And a GPU, like we talked about, highly recommended if you want to keep that latency super low. And Docker to make the deployment process smooth and easy.
Yeah, Docker seems like a huge win. So we can build this powerful real-time transcription service all running right on our home network.
That's the idea.
Awesome. All right, one last thing for everyone listening, something to really think about. What are the specific languages you need this service to handle most often? Think about that because it might affect which Whisper model size you choose. Because, there's always this balance between accuracy and speed depending on the hardware you have. So consider which languages are critical for you and how that balance plays out on your system.
It's all about finding the sweet spot for your specific needs.
Exactly. All right, that's our deep dive. We've covered a lot today, but hopefully you've got the key ingredients you need to build your own low-latency, multi-language ASR service.
It's an exciting project, and the technology is just getting better all the time.
Yeah, it really is.